Okay, let's take a look at today's lesson. We're going to be looking at counting principles. Probably you have some experience with this. I would bet in Algebra 2 you probably went through this. We'll just do this plus a little bit more. So let's talk about the fundamental counting principle. The fundamental counting principle is pretty straightforward. Let me give you an example. So let's say that I have 5 blouses, 2 pairs of pants, and 3 pairs of shoes to choose an outfit from, right? As long as I don't care if it matches, right? I could just multiply 5 times 2 times 3, and I would get the number of combinations that I could do. That's what the fundamental counting principle does for us. It allows us to take our options and list how many options we have for each individual event, and then multiply them together. Okay, that's what we'll be working with today. Two other things we're going to be looking at are permutations and combinations. So let's look at permutations. So permutations is where order is important. For example, if I were to say I would choose 3 of you, and the first person I chose would be like the president of the class, and the second person I chose would be like the vice president, and the third person I chose would be secretary. Would the order I chose you in matter? Yeah, it would, right? Because it would really it would be different if I chose you in a different order, because the first person would be the president. So that's where order is important. That would be a permutation. Order is important. I'm choosing 3 people, but it does matter which order I choose you in. So there's 3 different types of permutations we'll be looking at. One is, for example, we want to, let's say we have 7 different cards, and we want to know the number of ways we can order them. And each card is different, so the order would be important. So we would do 7 times 6 times 5 times 4 times 3 times 2 times 1. That would tell us how many different ways we could order 7 cards. If it was a little bit more complex and we want to do, like 2 things at a time or 5 things at a time, we want to do it a little bit more complicated, that would be this formula, this permutation of n elements taken r at a time. This I'm not going to require you to memorize. In fact, we're going to be using our calculators for that. I'll get to the calculator input in just a minute when I get to the examples. But we would just go to our calculator for that permutation and put the numbers in. And then the last one are distinguishable permutations. Distinguishable permutations. So that's where, let's say we have letters that we're putting in order. And let's say we have more than one A. Well, if I switch the A's, we're not going to be able to tell any difference between them, right? They're both A's. They look exactly the same. That's what it means by distinguishable. I want to be able to distinguish the differences. And so if we have a situation like that where we have actual exact duplicates of something, if we want to know how many ways we can order it, we would have to use this formula where the top number, n factorial, is the number of objects that I'm ordering. And then down here in the denominator, this would be the repeats of the objects that I would put down here. And I have an example like that, so hopefully that will help. So it just depends on how many repeats I have down there as to which numbers I would put down there. Okay? All right. So last type, and this should be a 3. The last type that we're going to be looking at are combinations, and combinations are where order is not important. If we go back to that example that I was telling you that I was going to choose 3 of you at random, if I just chose 3 of you at random and then we voted, on who was going to be president and such, would it really matter what order I chose you in? No, it would be different, right? The order would not matter. And so that's what a combination is where order is not important. It doesn't matter. And this is the formula that we use for combinations. Again, it's located in your calculator. These 2 particular formulas are in your calculator, so you don't really need to memorize them, but this one is not in your calculator. Okay, this one we will have to do by hand, but it's pretty easy to remember. It's just the total number, of the objects that you're ordering over the repeats. And we'll look at that. All right, questions before we go to the examples? No, this one we would need to memorize. This one we would need to memorize. And I'm not going to require you to memorize these. You're just going to use your calculator for those. So, but this one you would need to memorize. Okay. All right. So let's go to our examples. Let's take a look at our first example. So the first one says that we have telephone numbers in the United States have 10 digits. The first 3 digits are the area code and the next 7 are the local telephone number. How many different telephone numbers are possible within each area code? Okay, so here's the first restriction, within each area code. And then note the local telephone number can't start with a 0 or 1. So for problems like this, I draw out spaces. These are my objects that I get, the locations I choose from. So this is the area code, which really doesn't matter. And then our phone numbers we know are 3 digits and then 4 digits. Okay, so area code doesn't matter. So I typically, if I get to choose any number I want, I choose a number between 0 and 9. Those are 10 numbers, right? Including 0, there are 10 numbers. In this first space, I am told, I have a restriction. I'm told that the telephone number, the local telephone number, cannot begin with a 0 or a 1. So that means that I only have 8 numbers to choose from, right? 2 through 9. So there are 8 numbers to choose from. And basically, that's really the only restriction that we have. It doesn't say anything about repeated numbers or anything. So in the next space, I have 10 choices, right? I can use a 0 or 1 in there. And then I have 10 choices for all of those spaces. So this particular problem really can't be dealt with easily with just a formula. It really requires us to think through the restrictions that are happening. What we would do is we would multiply 8 times 10 to the 1, 2, 3, 4, 5, 6, 10 to the 6. And that's how many different phone numbers that we can have. It turns out that 8 times 10 to the 6 is 8 million. So there are 8 million different possible telephone numbers, local telephone numbers, within those restrictions. Okay, so you can see if we change the area code to a different number, we'd have 8 million more choices for telephone numbers. Okay? Questions on that? All right, let's look at number 2. On number 2, we have 8 horses are running in a race. In how many different ways can these horses come in first, second, and third? Okay, so I'm going to do this one 2 different ways. The first way is by using the blanks. You know, I want first place, second place, and third place. Okay, so I have 8 horses. There are 8 possible horses that could be in first place, right? Or 8. Now, one of them is in first place. So a horse, it's not possible for a horse to be in first and second place, right? It's either first or second. So I don't have 8 horses anymore that could come in second place because one of them has already come in first place. So that leaves me 7. I have 7 horses left that could be the second place finisher. Then one of them finishes, you know, as second place. So now I only have 6 horses left. So I multiply 8 times 7 times 6, and that's going to give me 336. So there are 336 different orders that race could happen in. Now that's with using the blanks. This particular one also can be used, can be found using a formula. So order matters, right? Order matters. Basically, what I have is I have permutations. I have 8 horses that I'm taking 3 at a time. That's what we have going on. Permutations of 8 horses 3 at a time. Let's go to our calculator and let's input that. So you will need your calculator for the lesson today. If you have it with you, it'd be good to get that out. Probably don't want to be doing all of this in your head. Okay, so let me get a little room over here. All right. So we're going to go to math. And then under math, there's probability or PRB, whichever version you have. So let's go to probability. You can see here on number 2 and number 3, number 2 is permutations and number 3 is combinations. And then number 4 is factorials. We'll be using all 3 of these in this unit. Permutations, combinations, and factorial notation. So we decided that that was a permutation, so that's number 2. So that pulls up my template, and I'm just going to plug in an 8 because there are 8 horses taken 3 at a time. and then I hit enter and I get 336, which is the same thing that I got with this. Okay, so we need to be cautious about what we use the formulas for and what we don't. Really, the formulas work well when we don't have restrictions. Was there any restriction there that was like, you know, one of the horses can't be in first or something because of X, Y, or Z? I mean, there weren't any restrictions, right? It was just there are 8 horses. How many ways can they finish first, second, and third? So that's when we are pretty successful in using a formula. So on the different operating system, what you would have to do is you have to put in an 8 first. You'd put in the 8 first, and then you would go pull down the permutation, and then put in the 3. Yep. Then that will work. Okay. Other questions on that? All right. So then let's look at. Okay. So I misspelled. Yes, sorry, I'm not an English teacher, as you can tell, so I have one too many N's in here. Just get rid of that one. Okay, so that's banana. There aren't 2 N's in the middle. So how many distinguishable ways can the letters in banana be written? This is one where there is no formula in your calculator for this. You're going to have to remember how to do this. I'm not going to give you this formula, okay? So the first thing I need to do is decide, we've got to count how many letters we have that we're ordering. 1, 2, 3, 4, 5, 6. I have 6 letters that I'm ordering. And so that's what goes in the numerator, 6 factorial. That's what goes there. 6 factorial, because that's the number of orders, that's the number of letters that I am putting in order. Now in the denominator, typically, really there is a space for every single letter. So how many B's are there? There's 1 B, so that'd be 1 factorial. You can see why we normally don't write 1 factorial, because it's just a 1. How many A's are there? Well, there are 3 A's, so that would be 3 factorial, and I'm multiplying these together. How many N's are there? And you can see there are 2 N's. And that's the formula. That's all there is to it. You just count the number of letters, you know, how many of each, like I had 3 A's, so I put 3 factorial. I had 2 N's, so I put 2. And so our calculator doesn't have this formula. We're going to have to do this. And to be honest, I know you're probably going to think, oh no, she's crazy. It would probably be faster to do this by hand than input this in the calculator. I mean, seriously. Because you're going to have to pull down the factorial. You're going to have to do 6 factorial over, 3 factorial times 2 factorial. It's just going to take a while. When in reality, this is really simple to do by hand. This would be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. I mean, that's all it is. Then we simplify. This 3, 2, 1 cancels with that 3, 2, 1. And this 2, 1 gives us just 2. So basically it's 10 times 6. And we can do 10 times 6 in our head, right? That's pretty easy. It's 10 times 6 or 60. So there are 60 ways that can be written. Could you use a calculator? Sure. I mean, you'll have a calculator for this. It's fine. But I do need you to know how to simplify factorials. That's actually for a later day. Are we okay with that? Okay. Let's look at number 4. How many different ways can 3 letters be chosen from the letters A, B, C, D, and E? Okay. So sometimes they're going to ask you to write them out, write the choices out. And I do have one like that on your daily work. So I do want to write the choices out, and then I'm going to use a formula to find the answer. I mean, we'll find it 2 different ways. So let's write the choices out. So I could do A, B, and C. I could do A, B, and D. I could do A, B, and E, and I've used all the A's and B's. Now we'll keep going on with the A. I could do A, C, and D. I could do A, D, and E, and A, C, and E. Okay, so I've finished all the A's. Now we're done with A, we'll go to B. So I could do B, C, and D, or I could do B, D, and E. Okay, so we have that. And I could do, what else could I do? B, C, and E. and we're done with B. And then the last one, I could do C, D, and E. Does order matter in this? No, it didn't matter, right? You don't see me renumbering this ABC so that CBA would be different than ABC, right? The order doesn't matter. And I'm counting these up. There's 8, 2, so there's 10 ways. 10 ways that could be done. Oh, that was 336. Okay, so there's 10 ways that could be done. So we just discussed that order doesn't matter. So this will be a combination of 5 things taken, 3 at a time. So if we go to our calculator, we can go to math, and then our probability, our combination, which is number 3. So that was, what was it, 5 things taken 3 at a time, and it gives us 10, which is exactly what we got when we counted it out. Okay. Alright, last one. So that was 10. You're forming a 12-member swim team from 10 girls and 15 boys. The team must consist of 5 girls and 7 boys. How many different 12-member teams are possible? This is another ordering problem. We want an order. So in this case, it's a bit more complex than the ones we've been working on. We actually have 2 different criteria. We need a certain number of girls and a certain number of boys. Does the order matter in the order that they're chosen? No. So this is a combination. So let's work, so this is there are 10 girls. So we have 10 girls and we're supposed to get 5 of them. So that's a combination of 10 girls chosen 5 at a time. Times. Okay, we're multiplying these options together. Now let's work on the other one. So for boys, we have 15 boys and we are going to have 7 of them. So this is what I'm going to put in my calculator to get my answer for this one. I need to multiply those 2 combinations together. So let's go to our calculator. Let me get rid of this stuff up here. Okay. Here we go. Let's go to our calculator and let's do this. So we're going to do combinations, which was math, probability, number 3. So we said that it was 10 taken 5 at a time, and I'm going to multiply that by, so times the other combination, so math, probability 3, and then we had 15 taken 7 at a time. And so that gives us, wow, that's the total number of ways that team could be chosen. You're like, what? 1,600,000? It's crazy. But that is the number of ways that a team can be chosen from that number of students. So we have 1,621,620 12-member teams possible. I really would not want to order that out, right? Just write all those out. This is good. We have a formula for something like that. Okay? So how are we? We okay on this?